Evaluating expressions that contain cube roots. So now it's just not just a cube root, but we got to do a whole expression thing. Okay? And since cube roots and cubes are opposite functions, and square roots and squares are opposite functions, they're with the exponent. They are actually on level with exponents. So when we're looking on PEMDAS, the cube root happens inside the E of PEMDAS. So we're going to do that first. So we've got 2 times something. It's going to be negative minus 3. And I have to do the cube root 216 if I don't have my calculator. Let's see. 6, 7, 8, 9. 3 goes into it. 7 times brings it 21, drops to 6, 72 times. Ooh, that's big. Okay, break 72 apart. Let's see, well, we can do it by 2. That goes 36, and break 36 into 6 and 6. 2 and 3. 2 and 3. Oh, I got 3 2s. And I got 3 3s. Because that's broke, that's broke, that's broke. So 2 times 3 is 6. So negative 6 is going to go right there. Now I do my multiply. Negative 12 minus 3. Going to get more negative. And that would be negative 15. Over here on B, whether it's inside the radical or it's outside the radical, if the exponent matches the root, you get to cancel that out. So 125 plus 21 is going to be 146. Yeah, that's a nice little trick there. Doesn't matter if it's x to the third or the cube root of x to the third. It's going to be just that base thing underneath. Those exponents cancel out. Okay. Here's more examples to practice, if you will. You can give this a pause and practice these, and then check what the answers are. Okay. We got to do the cube root part first. So 18 minus 4 times something. Let's see, 8. Breaks into 2 and 4. 2 and 2. There's my 3 2. So 2. 18 minus 8 gives you 10. That cancels nice and quick. Leaves us negative 64 plus 43. Let's see. That should be negative 23 when we do the math on that. Got to do the cube root first. 5 times something minus 19. Cube root of 5, 12. Let's see. 5, 6, 7, 8. 3 doesn't go into it. 2 does. See, 256. 256. Well, that divides by 2. That's 128. That divides by 2, which is 64, which divides by 2, which is 32, which divides by 2, which is 16, which divides by 2, which is 8, which divides by 2, which is 4, which divides by 2, and that's a lot of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 2s. 2 times 2 times 2 is 6. 5 times 6 is 30. So that would be 11. Doing and evaluating in an algebraic expression. So we have an expression. They tell us what an x is. We plug it in. We do the math. So 192 over 4 plus the cube root of 192 over 3. Sorry, it's supposed to be 2. Well, 2 goes into both of these things. Maybe even 4. Let's see. 192 divided by 4. B6 is 18. 4 goes into 12 3 times, so that'd be 63. The cube root of 192 divided by 3. That is not 63. Hello, Mr. Gets It Wrong. Yeah. Failure's always an option. 4 into 192. 4 times is 16 minus 3, 2 to be 48. There we go. Then 3 into 192. That's 6. 18 minus 12 is 64. Cube root of 64 would be 8 times 8. 2 times 4, 2 times 4, 2 and 2. Broke all those branches. Cubed 2's, cubed 2's. 48 plus 4, because a 2 comes out and a 2 comes out. 2 times 2 is 4. Should be 52. Plugging in over here, 9 times 127th plus the cube root of 127th. Well, put that on top. 9 goes into both. 9 goes into 9 once, goes into 27 3 times, so that's 1/3 plus. But we can do this in 2 pieces. We can do the square root of 1, square root of 27. Square root of 1, 1. Square root of 27, let's see, 3 and 9, 3 and 3. There's my cube, comes 3, so that's 2/3. 1/3 and 1/3, denominator's the same, so add the tops. 1/3 and 1/3 makes 2/3. Evaluating algebraic expression, just more complicated. So now we're plugging in the 6 there. So 5 times the cube root of 3 times 6 minus 9 minus 7 times negative 6. Sorry, it's a negative 6. Should get that right. So you got to do what's under the radical before you actually do the cubing. So 5 is the cube root of negative 18 minus 9 minus 7 times a negative 6 is plus 42. Negative times a negative makes positive. 7 and 6 is 42. 5 cube roots of negative 27 plus 42. 5 times whatever the cube root of 27 is. Just bring the negative down, then do cube root of 27. 3 and 9, 3 and 3. If you've got your chart, that'll go quick. You'll be able to find that on your chart, or you can use your calculator, cube root it nice and quick. Negative 15. Plugging in and then solving. The solving part's the hard part, is just doing the cube root. If you got the calculator, it makes it a little easier. If you got the chart, it makes it easier. If you got to do it by hand, still working that on there to show you. Now, modeling. Modeling means it's going to be a word problem. Just got to solve the wordy. Find the surface area of the baseball display case. Well, this is the question. So the surface area equals. And then surface area is length times width. So for us, that means side times side. Or the side squared. I need the value of a side. I know volume, and it's in cubic inches. And I know that volume equals length times width times height, 3 different ways. For us, this is a cube, a square cube, so that's side times side times side, just side cubed. That's what volume is. So if I know the volume is 125, and I want to know the cube root of those sides, cube root of s cubed is S, the side length. And then we got to break down 125. 5 times, let's see, quarters got, 100's got 4 25s. 125's got 5 25s. Break 25 down into 5 and 5. There's my 3 5s. So the side length is 5. So the surface area is equal to 5 squared, which is 25 feet. Nope, inches. Don't forget your units. Inches squared. Okay. So the whole point of this section is about cube rooting. That's what you're going to do. You're going to do cube roots in order to solve problems. So work on those cube roots. Calculate